Hey everyone, here's a video going through the first 4 problems on the worksheet for today where you're practicing multiplying polynomials. Multiplying polynomials, there are 2 rules you need to remember as we talked about. You need to multiply the numbers, which are technically called coefficients. I'll show you in a second, and then you need to add the exponents. And remember those rules that the bases have to be the same in order to add the exponents. Okay, so when I'm talking about the number part, for example, if I had 2x, the coefficient would be 2, and the variable would be x with an exponent of 1. Okay? All right, so in this first one, number 1, this is a very traditional distribution type problem. So you are still welcome in this situation to distribute that -2. I am going to show you how to do this with the box though, because we will be using the box a lot. The box is where I make an appropriate size box for our problem. This first one has one term in it, that's a monomial, and then the second polynomial has 3 terms in it. So I can make a 1 by 3 box, and you can make it go horizontally long or vertically long, it doesn't matter. And then I'm going to be stick the -2 on that left side, because that's a term by itself, and -8m squared, positive 8m, and positive 6 are going to go across the top. Now within each box, I'm going to multiply the 2 sides of that box for like the area. So this first one would be -2 times -8m squared. Well, I can multiply -2 and -8 together to get 16, and then I just have an m squared because there's nothing else that goes with it. All right, now for the second one, I have -2 times 8m. So again, I can multiply the -2 and the 8 to get -16, and then I have the m. And then the last one, I have -2 times 6, which is -12. In order to get our final answer, we will add all of those terms together, 16m squared minus 16m minus 12. And you can do plus a negative if you would prefer, but that is the answer to -2 times that trinomial. Let's do one that's a little bit trickier here just because it has a variable on the outside. We still have one term multiplying with 3 terms. So I'm going to make a 1 by 3 box. I'll stick the 8a on the side, and then the -4a squared, -2a, and the 3 across the top. Now I'm going to keep showing my little baby steps here with my mini problems. You don't have to do this every time though. In this first box, I'm multiplying that 8a with -4a squared. So again, this is a little bit trickier because I need to multiply those numbers. 8 times -4 is -32. And then I do have an a and an a squared. So if you remember back when we did exponent properties, this would be like a times a, which is actually a to the third. So that's why we can add those exponents together. In the second box, I have 8a times -2a. I'm going to multiply the numbers, -16, and then I have an a times an a, which actually gives me an a to the power of 2 when I add those exponents. And then the last box, I have 8a times 3. I can multiply the 8 and the 3 together to get 24, and then I just have that a. So the final answer for this problem, I should change my color, is adding all those terms together, and that is my solution. I cannot combine anything together. There's nothing that has the exact same variable and the exact same exponent, so that's all that I have.